Welcome to another edition of the Aussie Ideas Man. Thought I'd throw this one together fairly quickly. Hope I don't have to do too much taking out the silences in my speech, but every time I look at something on the screen, I go a bit blank in the head. Somebody had recommended this on Aptera Owners Club's latest video in the comments, and also recommended we watch this on my latest video. I took up the recommendation and watched this guy, Keith Gruber or somebody like that. I just called him the Groob, and he's a bit of a weird character just by looking at him. I don't know who wears ski glasses in the middle of the day, right in the centre of a car workshop, but it seems like this guy likes it, even keeps the ski hat on. In any case, I can't believe he's a mechanic. He's just some drip who's walked into a car workshop and tries to tell us lies. Once again, I've got a suspicion that Aptera has put him up to this and maybe slipped him a little brown paper bag for his efforts. But I'll tell you right off the bat that the main lie is that he says it reduces. This IWM that I have is in-wheel motors, and it reduces the unsprung weight of the vehicle. It doesn't. It adds massively to the unsprung weight of the vehicle, and that's what I'll mostly talk about. That's the big lie. I don't know how anybody who is any mechanic or anywhere near sensible knows anything about cars would say that in-wheel motors reduce unsprung weight. So anyway, I'll stop the video as I look through it and make comments as I see fit.
An exciting new technology is set to revolutionize the motor vehicle industry: wheel-powered motors. First of all, let's talk about what a wheel-powered motor is.
Wheel-powered motors is technically incorrect, so this guy doesn't know much about English to begin with. Wheel-powered motors means that the motor is powered by wheels, which is not what he means at all. What he intends to talk about is in-wheel motors, or motors that power wheels, not wheels inside motors that power the motor itself. That's a nonsense. So he needs to go back to school and learn English to begin with. Wheel-powered motors is a misnomer and is absolute rubbish to begin with.
Essentially, it's a motor that is built directly into the wheel of a vehicle, rather than having a separate motor somewhere else in the car. Before we dive into the benefits, let's review how traditional drivetrains, even electric vehicles, deliver kinetic energy to the wheels. In this Tesla Roadster, for example, we have a motor, a three-phase AC induction motor, about the size of a crock pot. That then couples into a transaxle, lots of gears in there.
The transaxle in an EV doesn't have lots of gears in it. It has one reduction gear, and so he's embellishing what an EV has already.
Eventually comes down to a couple of half shafts, and then we have U-joints or CV joints, 4 of them in these half shafts, before any kind of energy can get to the rotational portion of those wheels. The efficiency losses and wear and tear and maintenance can all be avoided with in-wheel motors.
There are energy losses as you use the reduction gear, the CV joints and the transaxles. There are minimal losses, and first of all I want to say that this guy is spruiking all the what he thinks are benefits of in-wheel motors, when there are so many things wrong with in-wheel motors that more than offset any benefits. And so this is why in-wheel motors have never been used in the whole history of cars, apart from rare occasions, both early and late, as we shall later see,
which include a number of benefits, both in terms of performance and efficiency. These in-wheel motors can be used both in the front and the rear wheels of a vehicle, and are designed to drive the wheels directly rather than using a drive shaft, or half shafts in this case, to transfer power from the motor to the wheels as in a traditional drivetrain. One of the biggest advantages of wheel-powered motors is that they allow for a much more efficient use of space and reduced weight, eliminating transaxles, drive shafts with traditional motor vehicles. The motor is typically located in the front and rear of the car, taking up valuable space that could be used for passengers, cargo, or fuel.
If you put motors in a vehicle, the motor takes up space no matter where it is. Now, if you have it in the car, in body I'll call it, if you have in-body motors, which is the normal way to do it, all you have to do is increase the size of the body to take the weight. You don't have to rob passenger space, you don't have to rob cargo space, just add what space you need to the body for the motor. You'd have many disadvantages by having the motors in the wheels, and in the case of Aptera, I'll go through what they are later.
With wheel-powered motors, the motors are built directly into the wheel, freeing up considerable space and weight elsewhere in the vehicle. And another advantage of wheel-powered motors is that they can improve the vehicle's performance. Because the motor is located directly at the point of propulsion, there's less power loss due to friction and other inefficiencies. This means that the vehicles with wheel-powered motors can accelerate more quickly and reach higher top speeds.
On the point of accelerating more quickly and reaching higher top speeds, it's not both. What advantage they have is a little quicker acceleration at the expense of top speed. In-wheel motors are neck-snappingly fast right at the onset, but peter out because of the rev limitations of the motor to a low top speed. They have pathetically low top speeds when they're in wheel. It's the reduction gear that takes some of that neck-snapping power away from the motor that isn't needed because there's too much of it, and turns the car into having a higher top speed. It's Peter pays Paul, it's one or the other. And by being in the wheel, you have no control over it, it's fixed, you have neck-snapping instant power, and you lose top speed. When you have a reduction gear, you can actually set it to what is optimum for the size of the motor and the weight of the car. The ratio of a in-wheel motor is 1:1. It has to be 1:1. It's impossible to be anything else. The motor and the wheel are together, and so it's 1:1. Now, if you want to make that 1:2 or 1:3 or any fraction in between, you can change that when you use the transaxle, and that's the beauty of the transaxle. And that advantage there more than offsets the fact that there's a little bit of energy loss through having the in-body motor away from the wheel.
And yet another major advantage of an in-wheel motor is that they can be used to reduce the unsprung weight of a vehicle, which can result in a more comfortable ride and better vehicle handling.
Get that, unsprung weight of the vehicle. This is the one that I really want to hammer home because this is an absolute lie. And I can't believe a mechanic would ever say this. This guy must have walked in off the street into this car workshop. Unsprung weight means that there are no springs to control the weight. And now when you put springs beside the wheels, the springs don't control the weight because the wheels are fixed sitting on the road. So you have basically three things, a little bit of sensors and stuff. But the three things with weight are the tyres, the brakes, and the wheel itself. And those three things are quite a weight, and they are unsprung, because after them come the springs, and above the springs, attached to the top of the springs, is the whole body, and that includes the motors when they're in-body motors. And they are sprung. When their weight is affected by any forces, they force the springs down and the springs react and control the weight. Sprung weight is at the top end of a spring, not at the bottom end of a spring. Unsprung weight is at the bottom end of the spring. And so he's saying that put the motor in the wheel and you've reduced unsprung weight. No, you haven't. You've done the opposite. You have increased unsprung weight. And this is how important unsprung weight is. Car makers have virtually stopped making steel wheels for cars unless they make the cheap and cheerful little cars with steel wheels. They stopped making steel wheels for cars and started using alloys so that they could save just a few pounds, sometimes grand because it's that important, but save a few pounds in weight to reduce unsprung weight. Aptera goes and throws a 50-pound motor in each wheel, which is roughly about the same weight as the whole wheel itself, so virtually doubling the unsprung weight by adding a motor in there. And that is drastically bad for handling, safety, everything. It's just bad because that weight in the wheel, which also has a rotating momentum as well, which magnifies the problem by a factor of 100 or more. What that does is when the wheels are going down into potholes or up into bumps, their forces are extremely massive, and there is nothing to help mitigate those forces. That's what springs do. That's why they call the springs a suspension system. The body and motor and everything in it is all suspended on the springs, and then the springs can deal with the forces that are acted upon it in movement. And the worst forces are potholes and bumps in the road. The undulations in roads create the worst forces. Of course, there's turning forces and other things, but you can work with those forces if you use springs. That's why the springs are there. The major thing is it makes it comfortable for the passenger to have springs, but it also mitigates the effects of sudden forces on the vehicle. And you can't do it on the wrong end of the spring, at the bottom of the spring. You are in trouble. So for the whole time car makers have been making cars, they have tried to minimize unsprung weight. This guy is selling us snake oil because he's saying put the motor out of the body where it was sprung into the wheel where it's unsprung and you reduce unsprung weight. Absolute nonsense.
Unsprung weight is the weight of the parts of a vehicle that are not supported by the suspension, such as the wheel hubs, the bearings, drive axles, differentials, and by reducing or eliminating this weight, a vehicle's suspension can more easily follow the contours of the road surface, leading to a smoother ride.
He's right there, but he's wrong about the fact that the motor actually adds to the unsprung weight. So he's saying how good it is not to have it, and then says put a motor in it and add to the weight.
In-wheel motors can also help to reduce the overall size of the vehicle because the motor and transmission are integrated into the wheel. The space required for the drivetrain can then be greatly reduced, and this can enable vehicles to be designed with smaller overall dimensions, which can be beneficial for urban and city driving as well as for parking and maneuvering in tight spaces. The Aptera vehicle comes to mind. Smaller cabin, smaller space, and smaller vehicle.
But the problem with the Aptera vehicle is it is the widest vehicle on the road, and the width of it is where the motors are, and that is dangerous. It's just a dangerous place to be. And in fact, because those wheels are outboard of the body altogether, they are susceptible to snapping off with any sort of contact with gutters or other vehicles or anything. It's just bad that they're sticking out like elephants' ears.
Which uses in-wheel motors. But don't think minimizing and reducing are the only options. It's not just electric vehicles that could benefit from wheel-powered motors. This technology could just as easily be used in hybrid and fuel cell vehicles, as well as in heavy-duty vehicles like buses and trucks.
I don't know how he can say you can do it with other things other than motors in the wheels, because I just can't imagine sticking a piston engine inside the wheels or anything else. If it's a hybrid, it can only be the electric portion that goes into the wheel. He's just selling snake oil, and if you think about what he says, it just doesn't make any sense.
Wheel hub electric motors are not a new idea. The Lohner Porsche petrol-electric hybrid of 1900, for example, was powered by electric motors built into the hubs of its big balloon-tired wheels.
Okay, so he says 1900 they tried an in-wheel motor vehicle, Porsche. So for 120 plus years, they gave it up. Why did they give it up? They must have had their reasons. If this was superior, it would have followed through with more and more cars having in-wheel motors. It was a bad idea in the start, and because it was a bad idea, it failed. Cars that are trying to put them in now are putting them in as gimmicks, and they have no advantages. When you test the cars don't perform as well as cars with in-body motors.
Today, in-wheel electric motors are to be found in plenty of EVs. It's just that none of them are mass-produced cars or SUVs yet. Furthermore, in-wheel motors can provide opportunities for innovative vehicle design. For example, by eliminating the need for a traditional drivetrain, the layout of a vehicle can be optimized for aerodynamics, passenger space, or cargo capacity. In-wheel motors can also help to reduce the environmental impact of vehicles by enabling the use of lightweight materials such as composites in the construction of a vehicle.
He says you can use composites inside the wheels. There's no reason why you can't use composites anywhere. This is snake oil. He's talking and people are just not thinking as they hear what he says. And so what he says is nonsense and nobody picks up on it. Composites are used in any part of the car.
All in all, wheel-powered motors are a very exciting development in the motor vehicle industry. In-wheel motors are an innovative technology that integrates the electric motor and transmission directly into the wheels of a vehicle. They offer a number of advantages over traditional drivetrains, including improved efficiency, increased torque control, and reduced unsprung weight.
He's just sold all the benefits when two of them aren't even true.
The technology also enables innovative vehicle design and can help reduce the overall size of a vehicle. With stricter emission regulations coming into effect around the world and a desire to reach carbon neutrality, in-wheel motors will become an increasingly attractive option for electric vehicle manufacturers, and we can expect to see these motors being used in a wide range of vehicles in the very near future. I'm Pete Gruber. We'll see you next time.
Now let's see what he's missed out on, and we'll take Aptera as the example, seeing that he thinks this is the great use of in-wheel motors. So you reduce the drive shafts. There's no drive shafts, but instead you have to have cooling channel go into the motors, and you really have to cool them down because those motors are right next to the brakes, and so anytime you stand on the brakes you create heat, and so the brakes heat the motors. The wheel spats or pant that they put on them actually keeps the heat in, so it exacerbates the problem. You maintain the heat because it's enclosed in the wheel pants with a hot motor and a hot brake right beside one another, helping each other to heat up. So the motor heats the brakes more. That means the brakes don't perform as well. And the brakes heat the motor, and that means the motor needs cooling more and needs substantial cooling channels going to it. It's just bad. Motor and brakes should be not that close together, and certainly not enclosed in something that keeps the heat in. I've told you the 1-to-1 fixed ratio that cannot be altered is a bugbear, and it's one that car makers don't want to have to deal with. You get too much neck snapping power and too little top speed, and we'll see that if ever they actually run Apteras on drag strips with the timing lights left on instead of turning them off deliberately. You will notice that. Also on that drag strip little bit of video where there's a race on, you will notice that they only run for 200 metres or so and not a quarter mile, not twice the distance, because it's in the second 200 metres where the speed rather than the acceleration comes into play. And what you would see is the Audi with its gearing go flying past the electric car. And likewise, for top speed, I'll guarantee you the Audi has possibly double the top speed of the Apteras. Of course, when we talk about unsprung weight, it's the danger of the wheels breaking because of the extra forces on them, but it's also the danger of poorer handling, and this is something that cars have to do. They have to take corners safely. The unsprung weight is a bugbear. So the major problem is the fact that it adds so much unsprung weight. The second problem is that it's stuck under an enclosed wheel pant with the hot brakes, and each affecting one another. The minimal losses in energy as you use other things like the reduction gearbox, the CV joints, the transaxles, those reductions are offset a little by the fact that you've still got to send the cooling out to the wheels because the motors are there. But even so, even though the cooling channels would be lighter than the gearbox and transaxles, etc., the in-wheel motors have to turn when the wheels are turned. So the forces on the power steering system are of greater magnitude than they are when there's nothing added to the wheels. It's not only the forces of the bumps in the forward direction, it's the turning forces as well. And so you're trying to turn your motor with the wheel, and the power steering system has to cope. It's just too much. It's not necessary if you keep the motor still in the body of the car. It's common sense that if in-wheel motors were superior, and they've been known to be available since 1900, we would have seen hundreds of cars made with in-wheel motors. Trying to sell the idea now is too little too late, and it's basically trying to con people into thinking that the engineering in cars has been useless for the best part of 100 years. Well, that's all from me. I can't believe the Aptera fanboys are as gullible as they are, but they must be. And all I can say is, until I find something else to educate people about, bye from me for now and stay safe.